Okay.
Hey everyone, so today I have my friend Jay on, and yeah, we're gonna do another coding interview. He's done one before, maybe 3 months back, so maybe I'll look back and see. We'll look back and see where he's at or how far he came. But yeah, Jay, you want to quickly introduce yourself? Maybe what school you went to, maybe
Yeah,
if
sure.
you work right now and companies you have interviews for and stuff, and then we'll get into like how many legal questions you solved.
Uh-huh. Uh-huh. So, actually, I'm a non-traditional CS background. My undergrad was in geography from U Chicago, but I'm getting my master's right now from UIUC in computer science. I'm a data engineer right now at this bio company, and I'm targeting basically anything right now. Um, I have Meta and Google coming up, but I would like to get something like Amazon just because they have an office in Phoenix and I
Nice.
really want to move out to the desert. I'm based in Chicago right now, so it's like the winters have been really rough on me. I'm
Nice.
at 200 leak code questions right now, or somewhere along those lines.
Damn, you want to live in the
Uh,
desert over the snow? So you're picking two extremes here.
yeah, and I'll probably be moving in the summertime too. So literally going from like freezing to 120 degrees Fahrenheit.
Why don't you just move to California where the weather is mild in between?
Oh, yeah, I mean, if I can afford it, I'm open to all opportunities right now.
Okay, cool. So you did around 200 questions. What's the breakdown of those questions?
And keep in mind these questions are like over the past like years, but so I've done 40 easies, 170 mediums, and
Wow.
like 10 to 8, 10, yeah, 18 hards. But most of those are just like me looking at the solution and then I just submit it and not sure if I could get those again.
Okay. Let's go. How good are you at arrays?
Um, I would say I could do the hardest I could do is some modification of Kadane's max subarray.
Okay, so
Yeah, I could do like
like
a
out of 10, out of
subsequence.
10, give yourself a rating out of 10. How confident are
I'd
you in
say
arrays?
seven.
7. Okay, Paul has one question. Are you doing those Meta and Google data roles, or that's software engineering interviews?
Uh, Google is software and Meta is data.
Cool. So arrays, it's 7. You're 7. Link list.
Linked lists. I would say an eight.
Okay. Trees.
Trees, six.
6.
Six.
Okay. Graphs.
Graphs. Like five or a
5.
four. Yeah, four.
Okay. Okay. All right. Okay. Cool. Let me look for a question. Just hop off the stream for now so you don't see what question I find, and I'm gonna invite
Mm-hmm.
you to the thing. Okay. Let me look for a question. All right. I'm gonna send you an invite to the first question.
Okay.
I'm gonna send it here.
Okay. Sum of left leaves. Is that the
Yep.
one?
Yep. Go ahead and just start. Yeah. Going
Okay.
through it.
Given the root of a binary tree, return the sum of all left leaves. A leaf is a node with no children. A left leaf is a leaf that is the left child of another node. Okay, so in the example, the left leaves would be nine, yeah, 9 and 15. Uh, and yeah, and it just can't be the root. Um, so 9 plus 15 equals 24. Okay, got it. So I would just traverse through this tree, and if I encounter a node that, well, if I need to know if it's a left leaf or a right leaf. So, okay. I traverse through this tree somehow, like maybe with a BFS or something,
Mm-hmm.
and I pick up. If I encounter a left leaf, I just add it to the sum. And let me think about how I'm going to determine if it's a left leaf. So it's a left leaf if, well, we have a node here, and then we have like node dot left, and then we have node dot right. Um, so I take a look at node dot left. If node dot left has dot left and dot right, oh sorry, dot right are both none, then it's a left node. I don't want to go down to the left leaf itself because uh, then I would have to keep track of if I came from the left side or the right side. So I'm going to only go down a level if I can verify that. Um, if I can, I'm only going to go down to the left if I can verify that if that it has children. So like let's say that we encounter an example where we have like four, and then we have like five, and then we have like six, and then we have like seven, and then eight, and then nine. So eight and nine in this case are going to be left left leaves. So let me just make sure that my algorithm kind of takes care of those. So I would have some kind of like BFS queue or whatever. So in the queue, I would have four, pop four, go down to five, or sorry. Okay, so in the BFS, I have four, pop four. Four has four doesn't have a right, but four does have a left, and the left also has a left, and the left also has a yeah, the left also has a left, or it has a right. So I go down to it. So I do, or maybe not a BFS. A DFS would is probably what I'm doing. Five, and then go down to six, and then six. I see that there's a node dot left, but there node dot left is none, and node dot left right is none. So it's a left leaf. So I add it to the result, and then I add, and then I do the same thing with nine here. Right? Does that make sense?
Yeah. So you're checking if it's a left node up here,
That's right.
and you're checking if it's a left leaf here.
I'd never really go down to the left leaf. Uh, in my mind, it's easier if I like to keep track of if it's coming from the left or the right. Because if I go down to a right node, um, I don't want to accidentally pick up this right node, this
Okay.
right leaf.
But how can we know at the right node if it's a left or right? Is there a way that we can notify it when we're visiting or when we're at that if it was a right or a left?
Um, well, I could, well, if I just don't visit the right node, and I only stay like a level above. That's kind of my original thinking. But let me think if there's a way that we can actually visit each node and not have this much nesting.
Yeah, it works, but we're doing like left dot left dot left dot left dot right. We're clicking in a bit
Yeah.
too much. That just looking for something a little bit cleaner.
Okay, gotcha. Let me think again. So dot right. Could I have a uh, mm, could I have a mm, left dot right? If the right node has well, I could, well, with each recursive call, so like I could, if I do the recursive DFS approach, I could pass down a flag that tells it if I came at it from the left or the right side. So like node and then true false. And if it's true, so if true, I came from the right, or I came from the left or something like that. That's kind of the only idea that's coming to me.
Yeah. So we're passing a flag. So from the parent, we're passing a flag down. So this one we're gonna pass down true, and this one we're pass down false because it's the right child kind of thing.
Yes, that's right. So like nine. So as we go down, so we start from four, and then we go down to five. Five is true, but seven is false. Since five is true, we're only going to, yeah, if five is true and we see that it has no children, then we add it to the result. But since it has children, we keep going down a level. So we give we pass down six true and then eight true. Eight is true and it has no children, so we do add it to the result. By the time we get to nine true, we also add nine. But since we're coming, since we're entering 10 with the false flag, we do not add it to the results.
Okay. What about right here? The root is it true or
Uh,
false?
the root is false because it doesn't have it is not a child, so it is false.
Okay.
So we
Yeah.
start off at false.
Okay. Go ahead and implement that.
Okay. Right. Let's start with. Let's take care of. Uh, okay. So let's start with the DFS function. Node is left. Right. So that's a boolean. Okay. So if node dot. So first check if leaf. If not node dot left and not node dot right, result plus equals um, node. Oh wait, if not node dot left and not node dot right and is left. Okay, so this is okay. Um, if it is a child, then we do nothing. But if node dot left, DFS node dot left true. If node dot right, DFS node dot right false.
Sure.
Okay, let me think what else. Um, some edge cases. So if not root, or and if it's a singular node, uh, let me see if singular node would be taking care of the edge case of singular node. Node, node dot right. Then we would just, yeah, okay. If it's a singular node, it would just fail all three of these if statements and just do nothing. Um, and then I'm just going to call DFS on the root false and then return results. And let me just do a dry. Does this make sense so far? I'm going to do a dry run.
Yeah. Do a dry run.
Okay. So let's go through my example. Okay. So result equals 0. So far we have 0. If not root, return run, fails that. DFS on node is left. So I'm going to start with 4 comma true. Oh, sorry, 4 comma false. So I check if it's a leaf, so not node.left. Fails that. If node.left, then I run DFS on 5 in true. And then I have to do DFS. Oh, yeah, no. There's no right child. So I just go down DFS 5 true. 5 is there is no dot left, fails this if statement, but there is a left child. So I'll do DFS 6 true.
Yeah.
And then I would do,
Let's just run the code now. I think, yeah, I think that
okay.
sounds good. Just try running the code. Looks like there's an error.
Okay. Oh, yeah. So, uh, okay. I'll just do this. Um, I think that should take care of it.
Nice. Cool. All right,
Okay.
let's move on to this next question. Good job. I think you
All right. Thank you.
handled the recursion well there. Yeah, I think, yeah, definitely improved from last time. Let's
Hmm.
see. Oh, okay. You just have to leave the last one.
Okay. Daily temperatures. Given an array of integers, temperatures, return an array and answer number of days I have to wait after the ith day to get a warmer temperature. Okay, daily temperature. Um, yeah, so for each, so it seems like the challenge for this question is, um, so for each given temperature, I just look forward in the array and just keep track of how many additional days it'll take for it to be warmer. But if the temperature is just going to go downhill from here on out, I give it 0 because it's not going to have any um, more warmer days. So so in this example, let's see. I don't have the skeleton code, but I
Yeah, what
can.
the heck is
Oh,
going on? It's so weird. Usually this is the skeleton code.
oh yeah. Okay. Is okay. So okay. It's the code isn't color coded, but whatever.
This is so odd.
It's
Okay, wait. I'll end it quick. Let's see. Okay, I'm gonna re-invite you. That was very weird.
sure. I mean, that's okay because these
Yeah.
sometimes they don't give you the IDE. Like you have to code on a Google Doc.
Yeah, it's fine. All right. It's working for you
All
now,
right.
right?
Yeah, it is.
Cool.
Okay, so working through the example of the this temperature. So um well, what we could do is we could do the brute force solution where we start where for each element of the array we just keep uh we we keep incrementing our second pointer a until we see a higher temperature,
Sure.
and that would be like the O of n squared solution. And so we want to so it's probably going to be more efficient than that. um I'm thinking maybe like a some kind of stack would be helpful, but let me think about it for a little bit. If we have 73 and then we get to 74, 70 73 goes to 74. So So are we adding to the stack if it's higher, or is it a decreasing stack? That's kind of what I'm stuck on. But I'll try what happens if it's decreasing. So if it's okay, so if it's 73, 73. So we start off with 73 on the stack. Okay. And then we encounter 74. 74 is greater than 73, so we pop 73. So we pop 73, put 74 on top of it, and then I guess and then we're gonna need to get a 1 from this. So we somehow produce a 1 from this logic. We encounter 75, pops 75. We compute 1. 71 is less than, 69 is less than, but 72 is greater than. So we popped 69. So we
Okay.
pop 69. We put a 1 here, and then since 72 is less than 79, we pop 79 and we put a 2 here, and or something like that. Um, yeah, am I warm or am I cold?
Just like, let me think about this. Like, let's just change this to like 69, 70. Right.
69, 70.
Okay. So, what would be the answer here?
The
Like,
answer,
just walk through this.
so first day, uh, first day 73. We look ahead. There, we are actually the greatest temperature, so it's a 0.
Or pretend.
69,
Let's go here. 75.
75. Oh,
So, what was your approach? You're gonna add 73 to a stack.
yeah, 73 to the stack.
Then what?
Then 69 to the stack. Then 70 to the stack, but 70 is greater than 69. So I pop 69. I'm yeah, I so basically a decreasing stack was my initial thought. And then once we get to 75, we're able to pop 70 and 73. Um, but I'm not sure how we get the numbers out of these. 1 1 because the answer for this would be 4 1 1 0. Maybe I could go the reverse side, or
Hmm.
or I could do like two pass throughs. Or no, no, no.
So, what's the problem here? You have one element here, right? You have one element, and you need to know when the next warmer day is, but you don't want to traverse there. Can't hear you.
Mm,
Oh, okay. Yeah.
I could um yeah, yeah, but oh, well, I guess the one observation I'm making is that 75 is kind of the warmer day for three of these. So like I guess if I'm traversing there, it may be not as bad as I was thinking originally, because we could just have like a second pointer that looks ahead to the kind of a global maximum temperature, and then so we do like, let's say this is J and this is I. we could just do like j minus I for each element. So j would be 3 minus I is 3. So we do like 3 here or something. And then we increment this. We increment I until we get to the point where they're equal. Um, okay, actually,
I think
maybe
you
this
mentioned
two
this.
pointers.
You mentioned this before, but like you're working from the front, but in order to work from the front, you have to kind of know you have to look further up the array. Maybe explore working from the back.
Mm-hmm. Okay, so let's say that I and J just start at opposite ends. Uh,
Or
so we
just working
start
from the back the whole time.
or
Like
just
no I
working
and
from the
J,
back.
no two pointers, right? Like
Sure.
you mentioned
Okay.
working from the back. Like you could think of explore what happens. 75. What should that? Is 75? Is there ever going to be a warmer day?
No, 0. So we just like add a 0 here. Okay. And then we go back to 70 and we just so like we have 1 here.
How do we know it's
We go
one?
back because I guess we could have like a running counter of consecutive days where the temperature decreases as we go backwards. Or no, we could have
This.
yeah, that's a good question. How do I know it's 1? We could have a we could because we have I know this is 1 because it's less than, and then I go back 1, but it's greater than, so I have to know to make this equal to 2. Mm, 2, 69, 68, 75, 2. Yeah, if I could have a days till, like if I had like some kind of variable days till here. So I started off with 0, and then every time I go back and it's less than, uh so every time I go back and I see that 68 is less than 70, add I add 1 to it, and
Okay.
then but like 68 I would 69 I would have to and then I go back to 7.
Oh, sorry, I can't. You cut out. I think.
And then if I had like 76 at the beginning here and then decrement this, so I reset to 76 and then I reset this to 0. Um,
I
but
think I, I,
how I'm
I I think the monotonic stack was also like the monotonic stack introducing that is a bit more warmer than where you're getting with right now.
yeah, okay, okay. Um, if I have if I have a all right, let's try the stack again, but working backwards.
Mm-hmm.
So 75, 75, 68, 68. let's say that we keep 68 on our stack. 69. Well, we don't. Okay, okay. We let's try a monotonically increasing stack. So, because 68, we're just going to skip 68 and put like a 1 here. And then 69, put like a 2 here. So every time we're unable to supersede the top of our stack, we just increment. So 73 would be a 3 because we've incremented 3 times and we still haven't beat the stack. But by the time we get to 76, we reset this to 0, and then we pop 75 and put
Okay, one second. I'm getting
76.
confused here. Um, so we're working backwards and we have a stack, right?
Mm-hmm.
So we're working backwards and we have a stack. Because you're saying it's like whatever, it's like it could be monotonic. Okay, and then we have some result. This is our result. Right.
Yes.
So 0, 0, 0, 0, 0. Right. Okay. So this is what we have. Okay, 75. What's the answer to 75?
Um, 0. The answer is 0.
Okay. And then what? Do we add it to our stack or not?
Mm,
So,
let's see. Yeah, I mean, I know the stack comes in, but I'm not sure what the stack should be describing. Uh, there
so why would we need to keep track of 75 here?
because we need to know that we need to know that 70. So to make sure that's for 68, 69, and 73, uh, to be able to, because it's the warmer day for 73, 69, and 68,
Yeah. So
but
we need
not
to
for
know 75.
76.
Yeah. That makes
So
sense.
75, right?
Okay.
68, 68, no. 69, no. 73, no.
Or what do you mean 68 no, 69 no? Like
68, don't add it to the stack.
as we're moving the integer, right? We should be updating the result. So 68 here. When's the next day that's hotter?
75 for
Okay.
68. So we add it to 1. Or if it's a monotonically decreasing stack, we could try um, we could try yes adding it to the stack, and then when we get to 69, we pop 68 and put 69 on here, and then that will be that'll allow us. Wait, okay. If it so 68, so we change this to 1. Now we're at 69. We see 68 and 75 on the stack. Um, then we increase it to 2, but I'm
Why
not
would we
seeing
say
a
two?
2 here. 2 because the length.
It's like what a monotonic. Okay, we're gonna add 69 into the stack, right?
Yes.
So if we need to add it to the stack, can we just add 69? Okay, you already popped out 68, right?
Yeah.
You already
Well,
popped
yeah, I
out.
popped
Okay,
off 68.
okay, makes it monotonic. Okay, um,
If I
basically,
have to pop it, I
do we know the
increase it.
difference between these two dates then, like by indices? Like we popped all of the ones in between, right? So like if we kept track of the
Mm,
index, can we figure out the distance between them.
Um, yeah, so we could do like 75 4, and then we would see 69 2. Mm, and then, well, we go from 68 3. 75 4. Okay. Well, we first of all we pop this, and then the top of the stack will be 4 in comparison to the two that our index is currently. So we know that the answer is 2 for this one.
Okay.
But then after we're done, we add it to like 69 comma 2, right? And then when we go to, like, for example, let's say that we change this here. We add like a 68 again, right? So 68, we see that our top of the stack is 69 2, or I guess, okay, I just inserted our example. So sorry, let me just change the indices. So once we get to 68, we see that the top of our stack is 69 3. Well, 3 is just one greater than 2, and we're currently at 2 right now. So we change this to a 1,
Yeah.
and then we pop. Do we pop it? No, we go like we go 68 2,
Yeah.
and then 73 uh we have to pop all of these until we get back down to 75,
Yeah.
and we see 5. Well, I'm at 1 right now, and the next one is the top of the stack is 5, so I put a 4 here. And then when we get to 76, well, our first job is to pop everything from the stack that is not and we see that the stack is empty, so this stays 0.
Okay. All right. Go ahead and
Okay.
implement that real quick. I have to
Yeah.
hop in a couple minutes, so.
Okay. So, and we're going to go. So I'm gonna have a for loop here, have a stack here. Our stack is so first pop everything from the stack less than me, and then second, uh, compare my current index to the top of the stack, and then add myself to the stack. So I am currently current temperature uh, is equal to while stack and stack -1, um, and then so the stack is going to have tuples temp index tuple, so and stack of 0 is less than cur temp stack dot pop. Okay. If stack and I wait if stack okay well if stack if there is no stack, uh answer is equal to 0, else answer is equal to stack -1 1 minus I. Yeah. And then And then okay, I'll have my result array now. So like that's 0 times length of temperatures. So res of I is equal to answer, and then stack dot append um, cur temp I. Okay, so dry run. My example here. So res is 0 times length of temperature. So I have I here, right? I start from the end here, 75. Current temperature is 75. Um, there is no stack, so the answer is 0. The answer is 0. So res result of I is equal to answer 0. And then I add myself to the stack. So 75, 0, 1, 2, 3, 4, 5. Okay, yeah. Um,
Cool. Let's submit the code. Wrong answer. You debug that
okay.
case.
Yeah, let's take a look at it. Wrong answer. Okay. Well, so so this is the wrong answer. Right. Let me think. So I start. So 70. So 70. That's 0. 100. That's 0. 76. That's 1. 46. That is well on the stack. I have 70. 46. Yeah, 46. That is 147. Oh yeah, I forgot about if they're equal to each other. So I need to add an equal sign here. I can try again. Okay.
Nice. Cool. How do you think you did?
Um, bad.
Yeah.
uh, well, I mean, I did eventually get it, but you had to give me like basically all the hints. So, yeah.
Okay.
It's just like if it's really difficult under pressure if you've never seen it before
Yeah.
to like talk through it.
Yeah. Honestly, you did pretty good, pretty better than the last one. I think. Yeah. Probably with the second question, I gave you too many hints, but you did show good coding skills, being able to code it up as soon as pretty fast with no bugs, and understand like you knew the monotonic queue stack. Sorry, the monotonic stack. You knew you kind of thought maybe we can work from the back. So I think the more thing with you is iterating through the different solutions and trying to figure out what way is gonna work. I think your coding has improved a lot from the last one. Your dry run was
Hmm.
really good because you're able to catch your error, and yeah, you got it working. So I would say, yeah, like the main thing I just had to give you too many hints. I don't know if I'd be able to pass you if I gave that many
Hmm.
hints in an interview. But it's not like you didn't know the concepts that I gave hints on. It's more of that you just didn't explore that path. So yeah,
Yeah.
like you're like, okay,
Yep.
let me just move from the front. So a lot of with these array questions, right? If you can't solve it moving from the front intuitively, try looking at it going from the back. There's pretty much only two ways that you can go through arrays: moving from left to right or right to left. Or yeah, even two pointers. Like, but I think a lot of candidates sometimes they forget that they can go backwards from it, and yeah, I think going backwards here is was a trick, and yeah, I think
Hmm.
now you'll
Hmm.
never forget to look backwards through an array. But
Yeah.
otherwise, you're
Yeah.
good.
Yeah. Well, I learned a lot, and I appreciate the practice.
Cool. All right. Thanks, Jay. Let me know how your interviews go. I'll message you again. If we could probably slot in another one. I really want to make sure you're prepared for those interviews. So I'll
Nice. Yeah,
schedule
I
it.
appreciate it. Hopefully, I get good RNG and they give me an easier question. But yeah.
Cool. All right. Catch you in the next one.
All right.
All right. See you. Bye.